So let's talk about diagonally dominant matrices. So the definition says that this: AII is greater than equal to the summation from j equals to 1 till n aij wait and j is not equal to I. So what does this mean? What does this mean? So let's take an example. Suppose our matrix A is this 7 2 0 3 5 minus 1 0 5 minus 6. So it is talking about the diagonal element. Okay, we take the absolute value of the diagonal elements. So what are our diagonal elements? 7 5 minus 6, and here our j is varying and I remains constant. If we look at this, j equals 1 to n and j is not equal to I, but I is not varying, only the j is varying, so it is going to give ai1, ai2, ai3 and up until aim. So we are moving across a row, we are moving across a row, right? So in a row, and yeah, we don't have to take the case of AII, right? AII, we don't have to take this, right? So, and this should be the diagonal element, the absolute value of the diagonal element should be greater than this sum. So let's see, 7. Okay, this is the diagonal element. If we take it, the absolute value, it is still 7. This should be greater than or equal to, okay, 2, right? We move across the row. We move across the row. This is the first row. First row here, the value of I is 1, right? So first row. So leaving aside this, leaving 7. Okay, 2. This is 0. Yeah, this is true. Let's take another example. Let's take now our second AII would be 5, right? Like it's the second row. Now we are talking about the second row. We always move in a row. Now if we see the second row, is it greater than 3 plus minus 1? Yeah, it is greater than that. Now if we take 6, yeah, it is greater than 0 and 5. Yeah. So yeah, this matrix is a diagonally dominant matrix. Diagonally dominant matrix. Now, if we take transpose of this, like if we take A transpose, will the matrix remain diagonally dominant? Let's check. So here we go. Let's take transpose of this matrix. So what will be the transpose? 7 3 0 2 0 2 5 5 0 minus 1 6, right? So again, let's talk about it. 7. The first, we'll see, mark the diagonal elements 7, 5, and 6. Now, absolute value of 7 is greater than 3 plus 0. Yeah, it is. 5. Absolute value of 5 is greater than 2 plus 5. Oh, this doesn't satisfy. So yeah, if this doesn't satisfy, so this is A transpose, we took, this is a transpose, we took the transpose. So if A is diagonally dominant, A transpose need not to be diagonally dominant, right? So A transpose not a diagonally dominant matrix, not diagonally dominant. So why this is important? This is important when you do, when you talk about Gauss-Seidel method and Gaussian elimination and Jacobi method. For example, you might have heard about Gauss elimination method. Gauss elimination method. In this, we basically we solve a linear system of equation by turning our matrix into a upper triangular matrix or a lower triangular matrix, and in that there's a thing called partial pivoting. So if when our matrix is diagonally dominant, then partial pivoting is not required. So if you know about it, then it's good. When matrix is diagonally dominant, partial pivoting is not required. Partial pivoting not required. Also, if you talk about those iterative methods of solving linear system of equations, we must have heard Jacobi method or Gauss-Seidel method, right? Gauss-Seidel method. You know, they work only if the matrix that the linear system of equation we are going to solve and the matrix that we have, if that matrix is diagonally dominant. Work only if matrix A is diagonally dominant, right? They converge to a particular value only if the matrix is diagonally dominant. There is another property of a diagonally dominant matrix. See, strictly diagonally dominant matrix. We talk about strictly diagonally dominant matrix. Strictly diagonally dominant matrix. So this in that case we had this definition, and this sign disappears, right? This sign disappears, and this will be a definition of a strictly diagonally dominant matrix, right? SDDDM, strictly diagonally dominant matrix. So why strictly diagonally dominant matrix is important? It's important as we can say for strictly diagonally dominant matrices. Strictly diagonally dominant matrices. The A inverse always exist. Always exist. I strictly diagonally dominant matrices are non-singular. Their inverse exists. Inverse exists. This is another property that you should keep in mind. See you.